Hi everybody. I am going to review factoring and solving for chapter 10. Some of you just did an excellent job on your chapter 10 test and some of you not so much, and I'm allowing everybody to make corrections. So this factoring business is super important, especially for Algebra 2. So I want to make sure everybody is understanding it. Please, please, please watch the videos. I posted some on chapter 10 corrections also, videos that is, so I hope that you're watching that. And also please send me more questions if you have any. So this worksheet that I've put together, worksheets I guess, that are due on Thursday, are a review of the different types of problems you might encounter when you're factoring and solving polynomials. Each page you would do just a little bit differently, so I'm going to show you one problem on each page that might help you answer the rest of the problems on that page. Also, keep in mind that everything going forward is a grade, being graded for fourth quarter, but in saying that, our grades are going to pass and or incomplete. So if you are not turning in work or your grade falls, in this case they say lower than a 65%, but I'm not sure your high school geometry teacher would be happy with a 65% as a pass. So I don't know, we'll just work through that and you can ask me questions about grading as we go, but just really it's the learning that's important, so let's please just try to understand it. So on page 1 here, I'm going to start with number 4. I just randomly chose number 4 as a problem. They're all pretty much alike. Okay, notice every single problem on page 1 has a leading coefficient. That's the number in front of the variable that's squared. That's 1. And I say it's 1. Visually, you're not seeing a number there. Nothing in front of the b squared. Nothing in front of the m squared, nothing in front of the n squared, but it can be a 1. It is a 1. Right? Okay, so on a problem, when you visually don't see a number in front of the letter squared, you're going to use the process I'm going to show you right now on number 4. You only use this process when you don't see a number in front of the x squared or m squared, etc. So this is the easiest version. You're looking for the two numbers that multiply together to make the third term, which is negative 12. So blank times blank equals negative 12. I don't know if this light is creating my shadow here. And blank plus blank equals 4, which is the number in the middle. All right. So my two numbers, what times what makes negative 12, but when you add them makes 4. If you're guessing, 1 times 12, too far apart. 2 times 6, 2 and 6, yeah, they're 4 apart. Which one has to be negative so that when you add them together, you get a positive 4? And the answer to that would be the 2. The 2 has to be negative. So you're going to write 6 and negative 2. Okay, this is not part of your problem. This is showing your work. All right, but there are the two numbers that you put inside your parentheses as, in this case, there's an n in there, so n plus 6 because it was a positive 6, and n minus 2 because it was a negative 2. All right, in the directions up here, I highlighted factor and solve. What we have just done is called factoring. This is the factored form. It is factored. One of the factors is n plus 6. The other factor is n minus 2. In order to solve this problem, I'm looking for x-intercepts. So like if this were the equation, quadratic equation, right? Quadratic equation, if I wrote y equals n squared plus 4n minus 12, x squared minus 4x minus 12. If I solve that, I turn that to a 0. Okay, what value for n makes n plus 6 equal to 0? You can write that as a separate problem. N plus 6 equals 0. subtract your 6 from both sides, and n would equal negative 6. I'm trying to write big. I could fit it in here. I'm trying to write large so that you can see it. You have to see the other factor as well. N minus 2 equals 0. So add the 2. Some of you on your test were getting the signs wrong on your solutions. Okay, they are not the numbers you're choosing to put into your factored form. Okay, factor it, that's this. Solve it, solve solutions. Okay, some people ask me some questions regarding their work on the tests, and once I put out the chapter 10 test response to questions, they said, oh, that helped a lot. They understood. So be sure that you're asking questions. Okay, all 10 of these should be similar to number 4. Factor it by finding your two numbers. Solve it by finding out what value would make each separate factor equal to 0. All right, page 2. Page 2 might be the toughest page, even though it's page 2. What do you notice? There's a number other than 1 in front of your variable that is squared. So there's a 4, a 6, a negative 6, a 16, a 6. I am going to do number 1 on this problem, or on this page, sorry. So number 1, when there is a number in the front, and share this strategy, by the way, with any parents that might be helping you, because what I'm noticing is there's some guessing and checking going on, and you're not getting the correct signs or pairs. Your parents and I were not taught this method that I'm going to explain right now. Show them that there's a process, and maybe they can go through the process. Or you can just try this and email me, and your parents do not have to be your teachers. So you're going to multiply the 4 times the negative 25. Multiply that leading coefficient with the last term. 4 times negative 25 equals negative 100. Okay? Now, that negative 100, that's what your two numbers need to multiply to equal. So blank times blank equals negative 100. But those two numbers still add together to make your middle term, which is negative 15. If you are struggling to find the numbers and you just quit, that's just giving up. You need to keep working on what times what makes those numbers. So I need two numbers multiplied together to give me 100. They could be 1 and 100. Whoa, they're 99 apart, too far apart. They could be 2 and 50. 2 times 50 makes 100. Still too far apart. That gives me 48, not 15. Does 3 go into 100? No. 4, does 4 go into 100? Yes, 25 times. But 25 minus 4 is 21, not 15. Does 5 go into 100? Yes, 20 times. Ding, ding, ding. 5 and 20, if I subtract them, are 15 apart. So these are my two numbers. Now I have to decide which one's positive and which one's negative, so that when I add them, I get a negative 15. So it's the 20 that needs to be negative, and the 5 that needs to be positive. Okay. This is going to become a 4-term problem. You rewrite that first term, 4n squared. You take your 5 and your 20, or sorry, your negative 20 and your 5. Negative 20, put an n on it, and your 5, positive 5, put an n on it, and you rewrite the negative 25. And then a lot of you, the last page of this, page 5, starts out like this, a 4-part problem, 4 terms. When you have 4 terms, you need to separate it into the front 2 terms and the back 2 terms and factor them separately like it's the opposite of the distributive property. In other words, you're finding the greatest common factor of 4n squared and negative 20n. What can you divide them both by? I can divide them both by 4. I also can divide them both by an n. So I'm going to take out a 4n, dividing 4n squared by 4n equals n. If I multiply that together, I get that back. Subtraction sign. 4n times what makes 20n? Or 20n divided by 4n is 5. Okay, this is the factored form of just this. Looking at the second factor, I'm talking about this. I'm going to divide by 5 because I can divide both of these by 5. This does not have a letter on it. These two both did. So I can just divide these by 5, a positive 5. I will be left with n minus 5. These two parts, these will always match. Always, 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 a promise. For your factored answer, the two parts that are separate come together in parentheses, 4n plus 5. And the two parts that are duplicated are just written once. If my directions are factor, this is my completely factored form. My directions also say solve. I'm going to keep going down here. Like I said, I'm just writing big so that you can see. Then I have to say, for what value of n would make this equal to 0, this factor? We've done this a long, long time. We're trying to find out, we're solving for n. So you're going to subtract 5 and divide by 4. So n would equal negative 5/4. That's one of your solutions. Okay, that's for this factor. If n were a negative 5/4, this factor would equal 0, and 0 times something equals 0, which would be an x-intercept. N minus 5 equals 0. You should just know it's 5. 5 take away 5 is 0. But if you're getting stuck, you're solving for n. There's your other solution. Okay. This is the factored form of this same trinomial. These are the solutions of that quadratic equation. They would be the x-intercepts. I think that is the most difficult problem. It's the lengthiest anyway, but show that to your parents because there is a process and they're probably just trying to guess patterns. If they're trying to guess patterns, I've seen things like this being the positive and this being the negative, which if you multiply it back out will not give you the correct signs in the problem. Okay, so you can check your answers. You can multiply this back out. It should equal this exactly. Okay, there's that page. Page 3. Page 3 is all about greatest common factor first. And then I think every single one of these fits into one of the special patterns that I think was either lesson 3 and lesson 7, I think. For chapter 10, lessons 3 and 7. You can correct me if I'm wrong, but if you need to go back and look, email me if that's not correct or message me on Google Classroom. Okay, I am going to do number 20. So I'm looking, I have two terms. I see and if I see two terms and a subtraction sign, by the way, I first check to see if this is difference of squares. But the number 7 is not a perfect square number, so it can't be difference of squares. So then I try to find a greatest common factor. Can I divide 343 and 7 by anything? 7's a prime number, so the only thing you're going to attempt to divide by would be 7. 343 divided by 7 is 49. When you're dividing and factoring, you need to keep those numbers outside the parentheses though. So I'm saying I'm going to divide them both by 7. They also both have a variable. The front term has b squared and the second term has b to the 4th. You can always divide both of them by whatever the lower exponent is. So I can divide these both by b squared. Meaning I'm going to divide the first term by 7b squared and the second term by 7b squared. 343 divided by 7 is 49. B squared divided by b squared is 1. So I don't need to write any variable there. Subtraction sign in the problem. 7 divided by 7 is 1. b to the 4th divided by b squared. This is why we did all those exponent rules. Subtract the exponents and your result would be b squared. You are not always done here. Okay, just because you took out a greatest common factor doesn't mean you can't keep factoring. So factor completely. This is now difference of squares. Perfect square number, perfect square number. What you divided by does not go away. It stays out front. How do you factor difference of squares? Square root, square root, square root of 49, square root of b squared, 1 plus, 1 minus. My directions still say factor and solve. This is my factored form. I am now going to solve it. Solving it means for what values of b would make this equal to 0. I'm going to start with the factors that are in the parentheses. 7 take away what makes 0? 7 minus b equals what? 0. Subtract 7. Divide by negative 1. B would be 7. That's one of my solutions. You don't have to show this work if you're good with this. Some of you are fine. 7 take away 7 makes 0. You should know that that value would be 7. If you're stuck, show your work. That's this right here. This one. 7 plus b equals 0. 7 plus what equals 0? 7 plus negative 7 equals 0. That's one of your other solutions. On this problem, because you have this outside here as well, these are like separate factors. The 7 is a factor, the b is a factor, the other b. 7 times b, okay? But if I solve it for 0, divide by 7, zero divided by anything is 0. Remember, you can have 0 divided by a number, just not the other way around. Square root of 0 is 0. So you have 3 solutions on this. If you go to Desmos and you graph this, go ahead, try it. It's kind of fun. Put this in the graphing calculator and graph it. It will cross your x-axis in 3 locations. Kind of cool. All right, so there's that problem. You have directions say solve. You have to list the solutions. Solutions, factored form. Watch your directions on your test. And we're on page 4. Page 4, I'm going to do number 3. Okay, it's a trinomial. It's got a number in front. You could take this number times this number. Whew, that'll give me a very, very big answer. I could look to see if there's a greatest common factor. 16, 40, 25, 25. The only thing I'm thinking is 1, 5, 25. Can't divide that by 5. You know, thinking about it, but it's not working out for me. My other option would be, hey, is this one of those special patterns at all? There's a perfect square. There's a perfect square. Subtraction sign only in the front. If I take the square root of this, 4b, square root of this, 5, multiply them together, 20b times 2, that gives me the middle term. This is one of my special patterns from, I think, again, lesson 7 if you want to check it out. So if this is a special pattern and you've memorized those, it comes in handy. Otherwise, you can factor this by doing the 16 times the 25 and going the same route as page 2. In the special pattern, though, you just take the square root of the first term, which would be 4b. Because there is a subtraction sign in the front, it would be a subtraction problem. The square root of the 25 is 5. And you would square it. That is the same thing. So on the test, some of you wrote a problem that was similar to this as something like this. Perfectly fine. These are the same thing. Squaring something means multiplying it by itself. We're good. Okay, so this would be factored form. But if I have to solve it, if I have to find the solution, and I say solution singular because I only have to do one of these, they are the same thing. 4b minus 5 equals 0. Add the 5 to both sides. Divide by 4. 1 1/4 or 5/4. That would be your solution. Factored form, solution, factor and solve. If it just says solve, you still have to factor it in order to solve it. Okay, that is that page. And the last page. What do you notice about all 6 of these problems? They all have 4 terms. And again, a lot of people struggled on the test, so go redo the problem on the test that has 4 terms. I think there's only one. Whenever you see 4 terms, and I'm going to do number 7, you break it up so that it has 2 parts. Separate the first 2 terms from the back 2 terms. Always with 4 terms. Okay, separate it into 2 parts. Factor out the greatest common factor of the first 2 terms. I can divide these both by 5. I can divide them both by v squared. So I am dividing by 5v squared. This divided by 5v squared gives me 5v. This divided by 5v squared gives me 1. When I factor this second pair, I better get 5v plus 1. What can I divide 30v and 6 by to get 5v plus 1? 6. The 2 parts that look like they're just a little separate or apart, these 2, come together. 5v squared plus 6 to make one of your factors. The 5v plus 1 you just write once. Again, show this to your parents. They're working too hard. Okay, that is my factored form. Ta-da. Factored. Solve. Solutions. 5v squared plus 6 equals 0. Or always setting them equal to 0 in order to solve. Subtract the 6. Divide by 5. Problematic. You cannot take a number times itself and get a negative number. Not a solution. Okay, that doesn't work. That doesn't mean there's not an x-intercept for this problem. That just means when I solved this, it didn't work. 5v plus 1, okay, that was 1. If I do the 5v plus 1 equal to 0, and I subtract 1, and divide by 5, I get v equals negative 1/5. that is my solution. It's my one and only solution. It's my one and only x-intercept. I'm going to try to get you to go to Desmos. Plug all that in. You can use x. 25x to the third plus 5x squared plus 30x plus 6. Look at that graph. It crosses the x-axis at -1/5 and only at -1/5. That's why this one didn't work. All right, there you go. Try all the other problems on this worksheet. Send me some questions. We need to get chapter 10 and this factoring business down to move forward. It's an interesting time, but please either send me a video, work together, send me an email, open a shared drive, and we can kind of type back and forth if you'd like. Whatever you have for a solution. Again, your parents don't need to be teaching you this. Go ahead and ask me. Thanks again, guys.